All right. Thanks for joining us, everyone. Today we're going to talk about Bluetooth, the differences between version 4 and version 5, and the new standard called Bluetooth Mesh. It's a bit of a technical overview, so thanks for joining us. Presenting today is Greg Nowak. He's a firmware engineer here at DornerWorks. He's one of our resident Bluetooth experts. So thanks, Greg, for joining today. My name is Eric Bigoness. I'm the Chief IoT Engineer here, and I'll moderate today's webinar. Just briefly about DornerWorks. We're located here in Grand Rapids, Michigan, where winter came back for the weekend, which none of us are excited about, but hopefully spring comes back on this week. We generally see ourselves as guides and developers of technology products for our clients. Our technology products are particularly tend to be embedded systems, embedded electronics. We have hardware and software engineers, and then we also connect those devices to the cloud and mobile apps, and so we end up using Bluetooth in a lot of our products. Just for size comparison, we're nearing 100 employees, and we're mostly engineers. So with that, I'll hand it over to Greg.
Thanks, Eric. So like Eric said, we are here today to discuss Bluetooth 5 and Bluetooth mesh networking. So first thing, kind of want to cover, just kind of orient ourselves as to where we are at with Bluetooth. And then we're going to talk about mesh networking, particularly Bluetooth mesh networking. And then we will talk about Bluetooth 5. So we'll talk about the kind of what has changed between Bluetooth 4 and Bluetooth 5. And then we'll kind of finish off with some current phone support for Bluetooth 5. Just kind of, it's a new spec, and we'll kind of explore what phones we know about that currently support it, and maybe talk about the future.
Before we get started, before we jump in, can we do a quick survey on mesh networking? So if you could take a second, you can see that tab. You just click how familiar you are with mesh networking. It'll give us a little overview and reference point.
Okay. So to orient ourselves a little bit with where we're at with Bluetooth, Bluetooth is kind of overseen as an industry standard. It's overseen by the Bluetooth Special Interest Group, or Bluetooth SIG. It's almost 20 years old. So version 1.0 was released in 1999. The biggest change between version 1.0 and 4.0, if we're talking about just core Bluetooth, is in version 4.0 was the release of Bluetooth Low Energy. It was kind of a change in the way we do things for connectable devices. If you think about headphones, you think about high bandwidth Bluetooth, you're primarily talking about Bluetooth Classic, or the Bluetooth kind of 2.0, 3.0 realm. Bluetooth 4.0 was Bluetooth Low Energy, and it was primarily focused on low energy devices, but having a lot of them. So if you think about small Bluetooth sensors, heart rate monitors, your fitness watches, all of those things are Bluetooth Low Energy. The latest version of the spec, version 5, was a big step forward for the Bluetooth Low Energy spec in trying to get back to some of the high bandwidth use cases of the original Bluetooth. And that was released in 2016, near the end of 2016. Mesh networking for Bluetooth was released in 2017, and it is a layer that runs on top of the Bluetooth 4.2/Bluetooth 5 core. So it's important to note that they are different. There's a different spec for Bluetooth Mesh rather than Bluetooth 5. A lot of people associate the two, but they're really two separate specifications. So you can have a version 5 chip that doesn't support mesh networking. You can also have a version 4.2 chip that does support mesh networking. So first topic is going to be mesh networking. So how is mesh networking different than your traditional point-to-point connection? If you think about a traditional Bluetooth connection, where a phone is connected to a single heart rate monitor or a fitness watch or something like that. You have one device talking to another device, and it's bidirectional communication. Everything happens between those 2 points. Mesh is different. Mesh is a network where you have multiple nodes that are connected to each other, and they all send messages to each other, and those messages are kind of forwarded through the network. We'll talk about the specifics later, but some of the benefits of mesh networking is it is resilient to having corrupt messages or messages that are dropped, because each node forwards those messages that it receives. So you have more possibilities for that message to get from its source all the way to its destination. It also allows you to have non-point-to-point connections talk to each other. So if you look at the graph, currently the dot farthest on the left and the dot farthest on the right can talk to each other even though they're not directly connected. So for Bluetooth 5, what were some of the design, Bluetooth mesh networking, what were some of the design goals? So if you look at traditional mesh networks, Bluetooth really wanted a mesh network, but have a low power mesh network. And most people think that this is kind of an oxymoron, because mesh networks require nodes to be alive all the time, constantly sending and receiving data, which means that they can't really be low power. And Bluetooth came up with a solution for this. Bluetooth mesh also wanted to have the ability to add new fixtures without adding new wiring. And we'll get into this more in the example use cases next. A flexible network structure. They wanted to be able to add nodes and remove nodes easily. Now, adding and removing nodes, you also have to have a concept of security. And Bluetooth mesh requires security. It is not an optional feature. So they built the security right into the spec. So you cannot implement a mesh network without implementing the security layers. Another design goal was to primarily focus on states. So this is not a lot of data. You're talking about transmitting around whether or not a light is on or off, or turning a light on or off. You're really conveying states. So it's really helpful for home automation and things like that. It is not going to be used for streaming data. We also wanted to support large meshes. So the idea is that these things are going to be placed all over the place through a large building. So you need to be able to support more than a handful of nodes. Bluetooth mesh also wanted to build upon the existing Bluetooth standards. So when this was being drafted, Bluetooth 5 was about to come out. So much of the standard is built upon the BLE stack for version 5, or at least version 4.2. So some example usage, lighting control. I think this is the most common one that you'll find in the examples. So if you have a warehouse or a large industrial site where you want to wire all of these lights together to be controlled by a central spot, but you're not going to be in radio range of all of the lights all the time. So mesh networking is pretty ideal for that. Sensor data is also a big one, and this is where the low energy side comes in. And we'll talk about that in the types of nodes that this can support. But the sensor data is a primary example of where the Bluetooth low energy standard, which is used for sensor networks, and the mesh protocol kind of come together. Location tracking, power and battery state, time synchronization, are a couple other examples, and then generic models. These things are on-off, things that can be turned on or off. It doesn't have to be a light. It could be anything that you can switch on generators, you can switch on a lot of things that just have a binary state. So that's really where the models come in. We'll cover a lot more detail later. So we're talking about mesh networks. First, we have to talk about what are nodes and how do you talk to nodes. So every object in the network is a node, and nodes can have multiple elements. And the elements are things that are individually addressable. And what I mean by that is, let's say that you have a light fixture, and that light fixture has 3 or 4 LEDs in it. And the node itself will be the fixture, and then the elements contained within it will be the LEDs. So at provisioning time, every element is assigned an address. And via configuration, you can create groups of addresses where you will group similar devices, similar elements. Virtual addresses are very similar to group addresses. And we follow the publisher and subscriber model. And what I mean by that is you will have an element, and an element will subscribe to a particular group. So if you think about an element being an LED and a group being the kitchen lights, the element will subscribe to the kitchen lights. And a switch will publish a message to that group saying, I want to turn off all of the lights in the kitchen. Or I want to turn off all the lights in the dining room. It's important to note that elements can subscribe to multiple groups. So you can have an element that is part of the dining room, and you can have a light that is part of the kitchen. So you can just turn off the dining room table lights, or you can turn off everything in the kitchen, which could include the dining room lights. So, and this allows you to easily add things onto the network, because the switch only really knows about the group. It doesn't have to know about the individual element. So you could add another dining room light, and the switch doesn't even have to know that a new light was added, because you're just simply subscribing another light to the group address. So I think it's important to talk about types of nodes. And so as I was saying, you have the kind of the design goals for low power. You have 3 types of nodes. The first is what everybody thinks of when they think of mesh networking, and that's a relay node. These are the nodes that are required to transmit any packet that they receive. So they typically are powered by main power. And what I mean by that is they are required to be on scanning and sending data nearly 100% of the time. Bluetooth 5, or Bluetooth Mesh, sorry, has a concept of low power nodes. And what this means is that these nodes are able to go to sleep because they are not required to relay information. They can wake up as often as their battery allows them to, and they can get the messages that are queued up for them. And they are queued up and stored on something called a friend node. These friend nodes are relay nodes that have special space allocated for their friends, and they will store the messages that are waiting to be retrieved. So if you have a mesh network and at the endpoints you have some sensors that want to be low power, they just have to pair themselves up with a friend, and that will cache all of the messages. So they can wake up every 10 seconds or every minute or however often they need to, and they will ask their friend, hey, do you have any messages for me? And at that point, they will respond accordingly and do whatever they were needed to do, and then they go back to sleep. So this really allows the power of a mesh network to exist even when you have low power. Now, everything in the standard and phones and tablets don't get updated as quickly as everybody would like. So Bluetooth Mesh has a concept of a proxy node. The proxy node is a node that can talk to a standard Bluetooth device, not over the mesh protocol, just using standard BLE, and it acts as that intermediate layer between, let's say, a cell phone and the rest of the Bluetooth mesh network. So right now, phones don't support Bluetooth mesh, but you still need a way to talk to the mesh network. So they have a concept of a proxy node. Proxy nodes are important right now. They'll probably become less important as time goes on, because as phones can just get right on the mesh network, they might be able to kind of get around that. But for now, proxy nodes make the mesh networking stack usable and you don't have to have everything updated. Otherwise, we would have to wait another year or so before phones that actually start implementing that. Models. Models is another way that has really helped Bluetooth 5 or Bluetooth in general take hold, I guess. A lot of people have really liked the idea of a profile. And what they mean by a profile in standard BLE terms is that if you have a heart rate monitor profile, it doesn't matter what the hardware is. As long as it satisfies the heart rate monitor profile, everybody knows how to communicate with it. So you can have a bunch of different hardware vendors implement the heart rate monitor profile, and then any phone on the market who understands how to communicate with a heart rate monitor profile can write an app for that. Models, on the other hand, are the same concept, but in a mesh networking, in mesh networking. So you can have trying to jump back and forth between the Bluetooth terminology and the Bluetooth mesh terminology. In Bluetooth mesh, you have a concept of a server and a client. The server is the thing that holds the state, and it holds the actions associated with that. And then the client is the thing that wants to interact with that server. So in normal BLE terms, you would look at that as more of a peripheral and a central device, where the peripheral device holds that data, serves that data, can be controlled by a client. The client, being a cell phone, can request the current heart rate, or it can turn that device on or off. In Bluetooth mesh, you have the same concept, where you can have a model that is the generic on-off model. And it doesn't really matter what's being turned on and off. Anybody in the mesh world can say, this thing is able to be turned on, turned off. I can also request the state. Is it on? Is it off? And that makes it very powerful for integration with existing switches or lights, things like that. So you can have any switch that can control the on-off model, and then any peripheral device that implements the on-off model can be turned on and off by that switch. It doesn't matter if it's a water heater or a light or a garage door open close. As long as they satisfy those states, it doesn't really matter what they're actually controlling. So how do you actually communicate? Bluetooth mesh uses something called managed flood. So it's an alternative to routing. And routing, for example, if you wanted to send a message from A to G, and a traditional approach, if it wasn't a flood approach, you would have to specify the route that it would take. In a non-managed flood, every single node would simply retransmit all the messages that it gets, and you could have a lot of traffic that way. But a managed flood is something where not every single message is going to be repeated, or the messages have kind of a time to live, and I'll get to that in a couple slides. All relay nodes will transmit, and what this means is kind of like we talked about before, they're required to be on the network all the time, so they will always retransmit the messages that they receive. What this allows is multipath and resilient message processing. So if you drop a single packet from A to B, it doesn't matter, because the message from A to C should have gotten there. And the chances of all the messages being dropped is pretty unlikely. I think we have some examples in the next couple slides, and maybe I will just move on to those. We can continue talking about the specifics. So if you look at this, a light switch is node A, a light is node G. And you want to send a message, and you want to say, I want to turn off light at G. When you send the message, nodes B, D, and F are considered relay nodes. And those guys will relay the messages that they receive. Bluetooth mesh has something called message caching. And what that means is that it will store the messages that it has previously received and previously retransmitted. So if you send a message from A to B, B sends it from B to C, and C sends it back to B, B isn't going to continually retransmit the same message. He knows which messages he has already relayed. So this cuts down on the noise and allows messages to only have a certain amount of life. Otherwise, you could have messages bouncing all around the network for a long time. Another important part is that you only relay messages that are on your own network. And we'll get into this on the security and provisioning side, but basically, if you can't decrypt the message at all, then you're not going to send it on. In order to cut down on how many messages are bouncing throughout the network, there's this thing called time to live, or TTL. And what that is it's a counter, essentially, that is put in the message, and every single time that message gets relayed, the counter goes down. And as soon as the TTL gets to 1, it is no longer going to be a rebroadcast. So what that means is that if you have a low TTL, that means it's not going to go through very many hops before it is no longer rebroadcast. Now, it's kind of hard to know in the beginning how far away node A is from node G. So there's a special heartbeat message, and that heartbeat message will keep track of the original TTL, and when it arrives, you will see kind of how many hops it took to get there. And this allows you to tune your network for the optimal number of retransmits. So this is really helpful if you have a really big network or a really small network. If you know everybody is really close, then you can set that TTL to a small value. If you're afraid that you have nodes that are really far apart from each other, then maybe only those nodes need to send it with a high TTL value when they're trying to communicate from A to G. But if A to B, you know it only gets there in 1 hop, then you don't have to send the message with a high TTL value. So, next thing we're going to talk about is security. I think everybody's interested in security, especially when it comes to mesh networking. We have an example here where you have 2 different network keys. And what I mean by network keys is when you have an unprovisioned node and you want to add it to the network, you have to add it to a specific network. And when you do that, usually you provision with something like a cell phone or a tablet. You give it the network key. And you only give it the network key of the network that it's trying to get on. So in this case, you look at the gray nodes and red nodes. The red nodes are part of a different network than the gray nodes. So if you think about this as like a hotel or an apartment complex, the red nodes could be a different apartment very close to you, but it could be a different one. And then all the gray nodes are your apartment's lights and switches and things like that. You don't want somebody in the apartment next to you being able to control your lights. So with different network keys, the messages that are sent are not forwarded on. If you can't even decrypt it at that level. You can have subnetworks, and those are a similar concept. They have a different network key. So you can restrict who gets to send what. Now, application keys are kind of one step higher than that. And application keys are important for if you want everything to be on your network, but you want applications that are running to have different permissions. So if you think about, let's say you have an HVAC system in your house and you have your lights and you have your switches that are controlling the lights, maybe that's a different application that's running and managing that, and you don't want the people who can turn lights on and off to be able to turn your furnace off. So you could have a different application key for those 2 things. So application keys are different than net keys in the sense that those messages will still get forwarded around the network, but the application layer won't be able to decrypt it. So if you look at the picture here, node A is part of both networks. He is part of app key 1 and app key 2. And if you look at A, B, and D, they're part of a different application space than C, E, and F. So messages will still get routed around. If A wanted to send a message to F, then it could still get routed from A to B to D to F, if you're following that path. Even though the application key is different, the network key is the same. So those messages will still get forwarded. On the other hand, if you look at B or BB and AA, they're part of the red network. If they send out messages and B, D, and E hear them, they will not forward those messages along because they don't have the same network key. So those messages will still arrive, they just gotta get dropped. Speaking of dropping, the deprovisioning process, it's important to note that Bluetooth Mesh has a key rotation built in. And what that means is that when you take your light switch and you throw it in the trash, somebody isn't going to be able to take your light switch and then get on your network. There's a certain key rotation that happens to maintain the network. And if it is no longer in the network for a certain amount of time, it'll no longer be able to reconnect to the network without being reprovisioned. And so that allows you to kind of rest assured that when you remove these things from your house, somebody isn't going to be able to hack into your network now. There's also kind of built-in preventions for replay attacks. And what replay attack is that if somebody's listening to the raw Bluetooth traffic and they receive that, they can't just retransmit that and expect to be able to, even though they didn't look at the message, they retransmit it and try and turn off your lights or something like that. Bluetooth Mesh has incrementing initialization vectors, and what that fancy term is just for that there's a certain amount of data that changes every time that message is sent, so that message cannot be resent later, and that allows or prevents people from being able to just mess with your network when you don't really want them to. So I think that is all that I wanted to cover for kind of an overview of the mesh networking side. And I think that, Eric?
Yeah, we have another poll we want to put up. And while we're putting that poll up, we got a question that came in. Grant wanted to know, do you have to manually make these node connections beforehand? Or would they automatically connect? So if they've got the same model, it's a light switch model, would it automatically connect and know I've got to listen on this light switch?
No, during the provisioning process is where you're going to set those up. So all that's going to be part of your node configuration. So nothing is going to be automatic about it. With some slight, how do I put this? Let's pretend that you do have a new light that you want to add. You provision that to the network. And when you do that, you, in your configuration for your new light, will have to configure it to what it's going to subscribe to. So if you say, I have a new light and I'm going to subscribe to the kitchen group, then that's the only thing you have to do. Turn on and off the things that are in the kitchen group. They won't have to know about your new light, because they publish messages to that group and your light has then subscribed to that group. So in that sense, it's not automatic, but it isn't as painful as it might seem. Like you don't have to go and update all your switches in your house to say, hey, I added a new light. Now I want you to turn this light on and off. Another caveat there is if you did want to have individual control of that light, then you might have to do something special to the switch to say, I want to create a new group, or I want to address this light individually, then sure, you're going to have some other steps there. But the network will be able to discover what has been connected to it, but it's during the configuration process that you'll tell it what you want to subscribe to.
Great, thanks. And thanks for your responses on that poll. Ready to move on?
Great. I think next thing we're going to talk about is the Bluetooth 5 overview. This is from the Bluetooth marketing, go faster, go further. And that's kind of the heart of what Bluetooth 5 wanted to do. People wanted to go faster and they wanted to have farther distances. So the Bluetooth 5 was the answer, or is the answer, I guess. So what's changed in Bluetooth 5 from Bluetooth 4? You have more physical layer options. I think it's important to note 5 PHY means physical layer, and that is the layer that actually talks to the hardware. That's the actual modulation rate on the radio that's going to send the bits over the air between the two transceivers. So every time I talk about PHY, which I'm going to talk about a lot through this part of the presentation, just remember that is the physical layer. You still have a lot of things on top of the physical layer, the actual protocol and communication and all that that will affect speeds. But so when I say 2 megabits per second PHY, it does not mean that you can send data at 2 megabits a second. So Bluetooth 5 added a couple different PHY options. For Bluetooth 4, you had a 1 meg PHY. And for Bluetooth 5, they added a faster PHY option to get twice as fast. They also added a coded PHY option that allows you to get 4 times the range. I think we'll talk about it more in detail later, but you can't have both. You can't have 2 times as fast and 4 times as far. You can either have it 2 times as fast or 4 times as far. They also added advertising extensions. A lot of applications use advertisements, use beacons, things like that, and they wanted to add more support for what a lot of the people were trying to do on their own. And frequency hopping was added to help with the noisiness of all of these things, all these new Bluetooth devices. You've got billions of them now. So they needed to add a way to kind of reduce the noise. So let's talk about some lingo. A lot of people get confused when they're talking to somebody about Bluetooth as to what version means what, and you hear a lot of terminology. So Bluetooth Low Energy, or LE, or Bluetooth Smart, Bluetooth Smart Ready, all of those things represent version 4.0 of the Bluetooth specification. Well, Bluetooth Smart was dubbed Bluetooth Low Energy and Bluetooth 4.0. Bluetooth Classic is the original Bluetooth spec, version 1.0 to 3.0. They have BR, EDR. That's a common term that you'll hear. And they still use it for audio, keyboards, things like that, things that require higher data rates. Bluetooth Smart Ready was the bridge between 4.0 and 2.0 because they were not backwards compatible. That Bluetooth Low Energy was really a break in the paradigm for Bluetooth. So they really want to concentrate on the low energy applications. So it kind of broke the, hey, I'm going to be connected, I can send data really, really fast, but you're going to chew through a watch battery. So the latest version of the spec is version 5. Note that it's not 5.0, it's version 5. They kind of dropped the 0.0 mantra just to simplify things, I guess. Not really sure. So if you hear people talk about Bluetooth, just note that there's a difference between when they say, I have got Bluetooth headphones, or I can stream this amount of data over Bluetooth, and if they say they're using Bluetooth Low Energy. And now they will say version 5. So choose your PHY. In the original, when I say original, I'm going to be talking about Bluetooth 4. I think it's important to note that this is primarily a discussion on the changes between low energy and Bluetooth 5. So there's probably a ton of changes between Bluetooth 5 and Bluetooth 1.0, but this conversation is primarily geared on 4.0 to 5.0. The normal low energy PHY was 1 megabits per second, and that's kind of what all of your standard stuff can talk to right now. Bluetooth 5 added a 2 megabits per second physical layer, and what that allows is for you to send data faster, twice as fast. It doesn't mean that your throughput's twice as fast because there's still some overhead that was added for Bluetooth 5 in order to support the 2 meg PHY, but it's pretty close to 2 times as fast. I think it's 1.7 times as fast or something like that. There's also a coded PHY, and what this means is coded PHY said that I'm going to decrease my bit rate and in order to get further distances. And that S equals 2, S equals 8 notation means that it used to send 1 bit as 1 bit. S equals 2 means I'm going to send 1 bit as 2 bits. So I'm going to send a 1-1 instead of just a 1 in order to use error correction. So if I send more bits to represent the same thing, I have a better chance of those bits arriving, and I can get further distances that way. So if I send 8 bits to represent 1 bit, it's going to be a whole lot slower, hence the 125 kilobits a second, but I can get 4 times the range. So I think I mentioned this before, but it's important to note that these are options. It doesn't mean that you can have twice as fast and 4 times as far, because the twice as fast is the 2 megabits per second PHY, and the 4 times as far is the 125 kilobits a second. So if you get 4 times the range, you're going to be a lot slower than you were even with Bluetooth 4. If you want 2 times as fast, then you're not going to get the added range that Bluetooth 5 has advertised. So it's important to note context to that. Bluetooth 5 really tried to give you options to match a bunch of use cases. Some use cases said, hey, I want to advertise a bunch of data, and I have all these beacons all over the place, and I want to beacon from 100 meters away. And Bluetooth said, great, we'll add something for that. And then somebody said, hey, I really want to be able to stream high amounts of data. So they added something for that. But the Bluetooth marketing material can look a little confusing when it says, hey, you can go twice as fast and 4 times as far. So just buyer beware. So throughput. A lot of questions that I get is, what is the rule of thumb for throughput? The answer is, there is no rule of thumb. It all depends. It depends on a lot of things, and I'm hopefully going to go through some of those right now. Version 5 had some improvements for throughput by doubling that PHY rate, but again, that's only in the 2 meg PHY option. If you go the other option, then you're going to be sending data a whole lot slower, and you're not going to get a higher throughput. So this is the basic equation. Bytes per packet, packets per connection interval, divided by your connection interval. And I don't know how familiar everybody is with connection intervals with Bluetooth, but connection interval is how often you're allowed to send data, that connection event. So if you have a shorter connection interval, that means you're connecting more often, and you theoretically can send more data, assuming that your packets per connection interval is fixed. So I assume everybody can do math just looking at the equation. Those are kind of the knobs that you can turn. So what are some examples? So if you look at some examples of Android and iOS, Android has, at least, I can't say it's Android, but Android phones have a typical packets per connection interval of 6 packets per connection interval. Now this can be kind of confusing because it depends on the phone. It depends on the actual Bluetooth chip that is on the phone. So it's not necessarily hindered by the OS, or not necessarily hindered by a particular version of the phone or version of the OS, as much as it could just be that the phone chip doesn't support it. Or it could be that the current version of Android doesn't support higher than that. If you look at some of the phone options, you'll see a wide variety of how many packets per connection they can send. 7.5 milliseconds is the Bluetooth spec fastest connection interval. Android says that they support 7.5 milliseconds. So that's why I kind of put it here as the quote-unquote typical. Version 4.0 and version 4.1, they had a maximum transfer unit size that would allow 20 bytes of actual user data per packet. So if you kind of run through the math and you say, okay, if I have 6 packets per connection interval, 7.5 millisecond connection interval, I can get 128 kilobits a second. Version 4.2 and version 5, they increased the MTU size maximum, called data length extension. So you could send 244 bytes per packet. I have 1.6 megabits per second in red there. And what I mean by that is that if you plug those numbers into the previous equation, you would get 1.7 or 1.6 megabits per second. But if you're using a 1 megabit PHY, it is physically impossible to send that many bytes in that amount of time. So in version 4.0 or 4.2, really, you could only really send 3 packets per connection interval if you were sending 244 bytes a packet, which limits your throughput to 780 kilobits a second. Now, version 5, using the 2 megabits PHY, you can get 5 packets per connection interval, which gives you that 1.3 megabits per second. Now, this is a theoretical maximum. Obviously, phones have other things to do, right? So they are going to limit you based on, and they usually limit you based on connection interval to say, hey, my OS is running too many things, I can't keep up. So I'm only going to support 50 millisecond connection intervals. iOS, Apple in general actually publishes some guides for peripherals, and it says, hey, I'm not going to support anything slower than 70 milliseconds or 30 milliseconds per connection interval, just because there are things that need to be done. HID peripherals can get that down a little bit to 20, but in general, 30 milliseconds per connection interval is a good average. 7 packets per connection interval was an average. I think the new iPhone says it supports like 7 or 8 packets per connection interval, but a lot of the older iPhones only support 4. And so those throughput numbers are kind of there. So what I did was I took a couple dev boards that I have, and I wanted to kind of see what actual throughput that I could get. And and here LOS is line of sight. So if I just took 2 dev boards, kind of put them next to each other, and this was with a data length of 27 bytes, and not that 247. So those are the typical throughput numbers, and I just kind of walked around the office, put some walls in my way, walked into conference rooms, things like that, to see if I could get some theoretical numbers or some practical numbers to kind of match up with the theoretical numbers. The 100-meter number at the very end, I didn't get a throughput, but I just managed to keep a connection, which was just sending a few bytes here and there. So, and that was at 100 meters away. So I was in the parking lot, a couple 100 feet away from my desk, and I was still able to maintain a connection. So I think the last thing we're going to talk about for Bluetooth 5 is advertising and frequency hopping. So advertising extensions, they wanted to add more ways in which you can broadcast data. Originally, you could only broadcast a 20-byte packet, and that was it. That was all you could do. So you could really only transmit 20 bytes from a beacon. So they added the idea of packet chaining. And what that was is that you could, in one packet, you could tell the scanner, hey, listen to channels 20, 23, and 27, and you're going to find more data from me. And they allowed you to transmit a lot more data that way by chaining all these packets together using the various advertising channels. They also changed the way that you advertise in general. Right now, or the previous spec, you advertise all of your data on channels 37, 38, and 39. What they do now is that they advertise what I'll call a pointer and say on 37, 38, 39, saying, hey, look at one of these other channels for my advertising data. And that allowed them to increase the packet size for the advertising data because you weren't going to flood up the advertising channels. So now you can transfer 255 bytes per packet. Higher duty cycles. So these things are on non-connectable things that just purely advertising. You can now transmit every 20 milliseconds rather than every 100 milliseconds. And they kind of made the advertising intervals more deterministic, so you can synchronize more appropriately and save some energy that way. You don't have to scan as long if you know precisely when the other guy's going to start advertising. Frequency hopping. So we still use the same 40 low energy channels, but Bluetooth 5 made it a little more intelligent as to how communication occurs. In Bluetooth 4.0, 4.1, 4.2, there were really only 12 hopping patterns. And what I mean by this is that when you first establish a connection, you establish a pattern that you're going to follow. So it's a next connection interval, or for the following connection intervals, I want you to go from 29 to 19 to 35. But there were really only 12 possible patterns. In version 5, they actually made that a lot more intelligent and made it a pseudo-random channel hopping. So now you kind of have unlimited patterns, and that really helps reduce the amount of noise and a lot of collisions that you would have. So if you look at an example, at the first connection intervals, you're on 29, the next one's on 19, the next one's on 35, kind of follow the arrows around. The next thing that Bluetooth 5 did is they added an adaptable, you have the ability to adapt when you run into high traffic channels. So in order to help kind of avoid interference, because all of these bands are shared with other wireless things like Wi-Fi. So the channel 0 through 7, for example, in that, let's say that they have high interference right now. And let's say in your hopping pattern, you go and you're supposed to be on 6. And you say, okay, well, this is a really, really noisy channel. I want you to use 8 instead of 6. And that allows you to have more deterministic, you drop less packets, you have less interference that way, and you can support a lot more Bluetooth traffic given the number of wireless devices we have right now. So phone support. Who supports Bluetooth version 5? Android 8.0 Oreo says that they're going to support version 5 of Bluetooth spec. The Samsung Galaxy S8 supports Bluetooth 5 right now, but not via the standard Android stuff. Samsung kind of wanted to be first, and they did their own thing, and they implemented their own Bluetooth 5 interface directly for the chip that's in their phone. Particularly for the dual audio support. They wanted to be able to sort of stream audio to 2 different Bluetooth speakers at the same time. So they added some custom software for that. iPhone 8 and iPhone 10 or iPhone X say that they support Bluetooth 5. Personally, I haven't tried it on the new iPhones, so but none of them support mesh. So I think that kind of goes back to the proxy node thing, that for right now, since no phone's going to support mesh, you're going to need these proxy nodes in order to communicate with mesh networks. So I think that is all that I had for the version 5 and version mesh. And I think I'm going to pass it back to Eric.
Thanks, Greg. We got one more poll we're going to put up. We want to see what you thought of this presentation, if it helped. And while we're pulling that poll up, a couple of questions came in here. So Basil, I apologize if I didn't pronounce your name correctly, but he's curious why, for the coded PHY, why didn't they drop the 2 megabits in half and get twice the distance? So if we are now allowed a 2 megabit PHY, why not do 2 bits to 1 or the 1 to 2 conversion and send it 1 megabits per second and get twice the distance?
That's a good question. To be honest, I don't know.
If you're keeping the same transmit power, I think what happens when we go up to 2 megabits per second is we're not getting the same distance we ever did at 1. I had to wager a guess. So you'd essentially be cutting your distance in half and then doubling again and getting back to the same. So I feel like you're not going to get that 2x off of version 4.2 if you did it that way.
That's a good question. Yeah, I hadn't really thought about it that way.
Right. Grant has another question about frequency hopping. He's wondering if it's automatic or does it change or happen on a per packet, between hops?
So it's kind of agreed upon at the connection time. So when you first establish that connection, your central and peripheral devices will negotiate the pattern that you're going to use. And I think with the exception of some of the adaptive, it's not going to be on a per packet basis that you say, hey, next packet send it on this, next packet send it on this. I think that's agreed upon at connection time. But version 5, I think, really added the ability to, if you start running into noisy channels, then they can say, hey, I want you to change our hopping pattern going forward to get off of these channels. But that's not on a per packet basis. I think that's on a, we're going to agree on, hey, do this for the future, for the entirety of this connection.
Great. Well, thanks everyone for joining us today. Just some contact info. If you want to get a hold of us, you can reach us at info@DornerWorks.com. You also can find us on Twitter. Just send us a tweet or DM us. We're going to put the slides up. We'll make those available. We mentioned that earlier in the chat. Again, just shoot us an email if you want information. Otherwise, we plan on sending out a link once those slides are up and available. And it's your move. We've hopefully given you an overview of some of the changes in Bluetooth 5, as well as an overview of mesh. So we'll make some great things. Thanks for joining us, and thanks, Greg.
Yeah, thanks, everyone.